Since July, the world has been watching 3A Atlas carve a bright, improbable arc through our solar system. An interstellar traveler moving too fast, too cleanly, and with too many unanswered questions. But by October, right when it finally became bright enough to study properly, we lost it. Not because it vanished, and not because it died, but because something closer and violently brighter stepped in front of our view. The sun. For ground-based telescopes, that meant a brutal blackout at the worst possible moment. The object we'd been tracking for months slipped into solar glare exactly when the physics should have become loudest. When heating spikes, when surface layers crack, when jets reorganize, when the coma becomes a chemical fingerprint written in light. By then we'd already seen enough to know this wasn't going to be a normal chapter. We'd started measuring strange molecular ratios. We watched the coma shift color more than once. And we saw something even more unsettling. A faint sunward-facing feature. A forward spike. A wrong-way tail. The kind of detail that online collapses into one word. Propulsion. Meanwhile, 3I Atlas was being hammered by radiation and tidal stress, racing inward at roughly 68 kilometers per second, fast enough that the solar system barely has time to touch it before it's gone again. So the question became urgent. Would it survive perihelion? Would it fragment into a train of debris? Or would it do something that doesn't fit the usual comet story at all? Welcome back to Beyond the Solar Veil. Tonight, we're going to reconstruct what happened when Earth went blind, using the instruments that never had to look away. We'll stitch together space-based observations from coronagraphs that can stare beside the sun. We'll follow the Mars flyby from a second planetary viewpoint. And we'll end with a faint radio fingerprint that cuts through dust and rumor alike. And before we go deeper, if you want calm, cinematic science stories where we follow the data into the dark, subscribe to Beyond the Solar Veil. This is an unfolding archive. And 3I Atlas is one of the strangest chapters we've ever had. Before 3, Atlas disappeared into solar glare. It left us a warning, not in dramatic flashes, but in chemistry. In late August and September, NASA's Swift Observatory turned its attention toward the inbound object. Swift is famous for gamma-ray bursts, but what matters here is its ability to see the invisible, especially in ultraviolet wavelengths, where comets reveal what they're really made of. One of the cleanest tracers is hydroxyl. A fragment that forms when sunlight breaks apart water molecules. If you can measure you can estimate how much water is being released, even when dust and glare complicate everything else. And Swift detected something that made researchers stop and stare. A surge in hydroxyl so strong it implied 3 Atlas was dumping water at an estimated rate of around 40 kilograms per second, while it was still about 2.9 astronomical units from the sun, nearly 3 times Earth's distance. Out there, temperatures are still brutally low. And in standard models, water ice shouldn't behave like a runaway engine at that distance. That mismatch is important because it hints at mechanism, not just magnitude. If the nucleus were simply warming at the surface, you'd expect a slower climb. But a violent surge that far out suggests the coma may have been seeded with icy grains. Tiny particles ejected from the surface that dramatically increase total surface area. Each grain becomes its own little radiator, warming and releasing vapor independently, turning a single nucleus into a swarm of microsources. It's the difference between one solid block of ice evaporating slowly and a cloud of icy dust turning the coma into a massive active interface. In other words, the fire hose wasn't necessarily a thruster. It was physics amplified by geometry. Then, just as the story was accelerating, 3 Atlas slipped behind the sun and disappeared from Earth's line of sight. Throughout October 2025, ground-based observing went quiet. The nightmare scenario where the most violent phase happens out of view. Solar heating peaks, outgassing intensifies, jet geometry can flip, and surface layers that survived interstellar time can fracture in weeks. But Earth is not the only observer. Across the inner solar system, spacecraft carry instruments built for solar weather, coronagraphs designed to block the sun's disk and reveal the faint corona. Those same instruments can also reveal comets skimming the glare, provided you know where to look. Researchers, including Qiqing Zhang and Carl Badams, combined observations from platforms like Stereo A, SOHO, and GOES 19. And what the coronagraph saw was not a gentle continuation. It looked like a metamorphosis. For months, 3E Atlas had been brightening in a way that looked comet-like. Astronomers often describe brightness as a power law with distance from the sun, Ra. Before October, the brightening scaled roughly like R to the minus 3.8. Active, but believable, consistent with sublimation, and a coma gradually thickening as sunlight climbed. Then inside about 2 AO, the slope didn't just steepen. It surged into a regime that strains the quiet, dirty snowball expectation. The aggregated data suggests the scaling jumped toward something like R to the minus 7.5. An explosive rise. That kind of curve is what you see when a nucleus exposes fresh volatile-rich layers, when a crust collapses or peels away, or when an outburst injects enough material into the coma that the effective emitting area balloons. It doesn't require intelligence. It requires access, sunlight finding new material, and new material finding a path out. When the object finally emerged from the glare, it was bright enough that even modest amateur setups could capture it again. A strong coma, a long sweep of material, and a nucleus still hiding deep inside its own output. But the most telling detail wasn't brightness. It was color. Earlier in the campaign, observers described 3E Atlas as red, consistent with dust-rich Comet and organic-coated surfaces, materials that scatter sunlight in a way that warms the hue, the kind of look associated with radiation-processed crusts and necrusts, carbon-rich dust. Then it turned green in Earth-based observations, a familiar cometary sign, often linked to carbon-bearing species and coma photochemistry. Yet in coronagraph datasets using specific filters, the coma appeared distinctly blue relative to the sun. In comet science, a blue coma often points toward gas emissions such as carbon monoxide, CO, and radicals like NH2. Signatures that can dominate when dust becomes less important and volatiles take over the light budget. The simplest picture is a shedding. A dusty cloak breaks or blows off, and the volatile engine beneath finally vents hard enough to rewrite the object's spectral identity. The color shift isn't cosmetic. It's chemistry announcing a transition. And the solar probes weren't the only watchers. Just before the solar encounter, 3 Atlas swept past Mars at about 0.1990, around 28 million kilometers. Still far by human standards, but in orbital terms a rare alignment, and a chance to observe from a different baseline. NASA's Mars Reconnaissance Orbiter aimed high-res at the visitor, one of the sharpest cameras ever sent to another planet. If anything could resolve a nucleus, it would be this. But when the images arrived, they didn't deliver a crisp close-up. They showed the nucleus swallowed inside a bright shroud of dust and gas. Visually underwhelming, scientifically useful. Even a non-detection constrains size, because it tells you the central body is small enough, and the coma thick enough, that the core stays unresolved even at that geometry. Other Marsasets added context. Ultraviolet instruments traced extended hydrogen and coma structure, and from the surface, Perseverance pointed its cameras skyward for long exposures. In those images, 3I Atlas appears as a faint, ghostly smudge among the stars. Subtle, almost easy to miss, and for that reason, even more haunting. It is, in a quiet way, one of the most extraordinary perspectives we've ever achieved. An interstellar visitor recorded from the surface of another world. As 3I Atlas re-emerged from behind the sun in November, speculation spiked. Fragmentation rumors spread, and some commentary framed the behavior as potentially anomalous, citing the apparent sunward jet and non-gravitational acceleration as if they were signatures of intent. The internet loves a clean binary, comet or craft, nature or navigation. But both features have strong natural explanations rooted in ordinary comet physics. A sunward-facing spike can look like a thruster, yet it's a known comet phenomenon. The sun-facing hemisphere heats rapidly. Weak spots vent gas and dust, and solar wind shapes that flow into fan-like structures that can project forward depending on viewing geometry. What looks like a wrong-way tail can be a perspective effect layered on real outgassing. And non-gravitational acceleration is, in most cases, the Comet rocket effect. Mass loss produces momentum, and momentum nudges the orbit. If the object is shedding material rapidly, especially in asymmetric jets, its path can drift slightly from pure gravitational predictions, and that drift can be modeled. In hyperbolic orbits, the path can also appear unusually straight, simply because the object is moving so fast that gravitational curvature is less dramatic to the eye, even though it is still following predictable dynamics. Then came the measurement that mattered, because it cuts through dust: radio. In South Africa, the Meerkat array detected a faint but distinct signature at 1665 and 1667 MHz, frequencies associated with hydroxyl transitions. This matters because radio observations can penetrate dust clouds that scatter or block visible light. Optical can mislead when dust dominates, but radio can track gas more directly. The detection supports water-derived chemistry. Not just a vague "it has a coma," but a specific molecular fingerprint tied to cometary processes. And it carries a larger implication: a dry metallic object, a dormant rock with no volatile inventory, would not naturally produce the same O signature in the same way. This doesn't solve every mystery, but it anchors the object where the data keeps pulling us, toward an active, volatile-rich body. If you were hoping for a clean alien probe ending, this is one of the strongest signals pointing the other way. But natural doesn't mean ordinary. One of the most unsettling ideas to emerge from recent discussions is that interstellar objects may rarely be pristine. We imagine them as perfectly preserved time capsules, unchanged since their parent systems formed. Yet interstellar space is not gentle. It is a long-duration radiation chamber. Over billions of years, galactic cosmic rays can penetrate surface layers, break chemical bonds, rearrange molecules, and build complex organics and oxidize species. In that picture, 3 Atlas isn't pristine. It's processed, cooked, its surface rewritten by deep time before it ever met our sun. Infrared analyses have been interpreted as suggesting a volatile inventory that looks extreme compared to many familiar comets, with unusually strong carbon dioxide relative to water. One proposed mechanism is long-term irradiation, converting simpler carbon-bearing ices and water into CO2 and refractory organic residues, building a chemically altered crust that could extend meters to tens of meters deep. If that crust then peels away under solar heating, the object can switch regimes fast, and the coma can surge as fresh layers are suddenly exposed. Then there's another layer: metals. Spectral work has discussed detections of elements like nickel and iron in the coma, and metals matter because in the presence of water and carbon compounds, catalysts can enable Fischer-Tropsch-type chemistry, reactions that can release heat. If heat release accelerates melting, melting exposes more reactants, and reactions release more heat. You can build feedback loops. You don't need science fiction to get sudden outbursts. You only need pockets beneath a crust where pressure accumulates until the surface ruptures and jets explode outward, briefly rewriting the brightness curve and the shape of the coma. And this is where the story becomes quietly profound. 3i, Atlas has already taught us something uncomfortable. The space between stars is not empty. It is an environment, a slow furnace of radiation and time that transforms everything drifting through it. It has shown us that small fuzzy objects can carry chemical engines powerful enough to flare, to peel, to survive the sun's inferno and still keep venting on the way out. And even if it isn't a spacecraft, a body of ice and dust that wandered for billions of years, crossed the gulf between stars, and survived long enough for us to measure its breath is, in its own way, miraculous. If you want the next chapter the moment new data lands, subscribe to Beyond the Solar Veil, because the story isn't over when it fades from our skies. The story is over when the universe stops sending visitors, and it hasn't stopped yet.